So now the video of the grant test 2. So we'll start. So question number 1 they are saying is unit of electric flux R. What is electric flux? First thing we'll discuss. What is electric flux? Electric flux phi is equals to closed integral of E dot ds vector. Now I care about only unit. It is Newton per Coulomb. Electric field is what? Newton per Coulomb. Force per unit charge multiplied by meter square. Now in the option Newton per Coulomb not given, Newton per Coulomb square is there. And third and fourth option in volt per meter. So we will try to convert it into volt. Okay. We already know electric field is volt per meter. Electric field is volt per meter. So the same thing I'll write volt per meter into meter square. 1 meter meter cancel, volt into meter. So electric field is volt into meter. Right. So option number third, volt into meter is the correct answer. Now second question they are saying is if the direction of initial velocity of the charged particle is neither along nor perpendicular, means at an angle theta to that of magnetic field, then orbit will be a helix. Helical path will be there. Case 3 we have discussed in the class. Motion of a charged particle in an external magnetic field, that when the charged particle was parallel to the magnetic field, or velocity of the charged particle is parallel to the magnetic field, the path is a straight line. When charged particle is perpendicular, motion of the charged particle or velocity of the charged particle is perpendicular to the magnetic field, circular path will be there. And charged particle, when it is making angle theta from the magnetic field, then a helical path will be there. Okay. Now next question they are saying the mass of an iron rod is 80 gram. Mass of an iron rod is 80 gram. Mass of an iron rod is 80 gram and its magnetic moment is 10 ampere into meter square. If the density of iron is 8 gram per centimeter cube, 8 gram per centimeter cube, then the value of intensity of magnetization will be value of intensity of magnetization. In the previous class, we have already seen, like yesterday's lecture also, intensity of magnetization H is equals to magnetic moment divided by per unit volume. Magnetic moment per unit volume. Magnetic moment they have given as it 10 ampere into meter square. M value 10 ampere into meter square means basically we have to find the volume. Volume is mass per unit volume is density. So that volume is mass per unit density. Mass 80 gram and density 8 gram per centimeter cube. Sorry, centimeter cube. CC. Gram is okay, but centimeter cube we will change it into meter cube. Okay. So volume 8 10 upon um, centimeter cube 10 to the power minus 2 to the power 3, 10 to the power minus 6. 10 to the power minus 6 will go above minus 6 meter cube per gram will be the volume. 10 to the power minus 5, gram to gram cancel already. Already mass is in grams. So this will be 10 to the power 5 meter cube. So 10 upon 10 to the power minus 5 ampere into meter square upon meter cube. This 2 times cancel. 10 to the power 1 plus 5 ampere per meter. 10 to the power 6 ampere per meter. Question number 2. 10 to the power 6 ampere per meter. Right. Now, question number 4. Two bodies of unequal masses m1 and m2 are dropped from the same height. Are dropped from the same height if the resistance offered by the air to the motion of the both bodies is the same. A resistance offered by the motion of the both bodies are same. The bodies will reach the earth at the same time. See, if the resistance is same, then also the air, although resistance is same, air resistance depends on the mass, and the net acceleration will depend on the mass. Net acceleration will be acceleration of due to gravity minus the resistant acceleration, right? G minus A. With this acceleration, it will be falling down. So that acceleration, net acceleration will be depending on mass. But air resistance depends on mass. Acceleration due to air resistance depends on mass. Hence, the body will not reach Earth at the same time. First thing. So assertion is wrong. False. For equal air resistance, acceleration of fall of masses m1 and m2. Okay. M1 M2 will be different. Equal resistance also. That's what I'm telling you. Acceleration will be different. So reason is true, but assertion is false. Option 4. Now the next question, question number 5. A beaker containing water is kept on a spring scale. The mass of water and beaker is 5 kg and a block of 2 kg and specific gravity 10 is suspended by means of thread from a spring balance as shown. The reading of the scale S1 and S2 are respectively. Now see, S1 is connected to only beaker and S2 is connected to the body. So I will draw it properly and then I'll solve. So first thing, there is a beaker. In this beaker, water is there. Now here spring 1 or 2, S2. S2 is connected to the body of mass 2 kg and this beaker, the scale reading and right, and this beaker is connected to spring S1. The mass of the beaker is 5 kg. Now the forces acting on the 2 kg body. See, 2 kg body is coming down. Okay, downwards. So on S2 spring upward, spring force will be there. 2 kg body force acting. For 2 kg body, spring force Fs2 upward, upthrust given by water. Water and beaker both are applying upthrust on the 2 kg mass upward. If water is applying some force on 2 kg mass, then the 2 kg mass will apply same amount of force on the beaker also, upthrust downward also will act on the beaker. Okay. And on the body 2 kg mass multiplied by gravity. This force is also acting. We need a reading of Fs2 first. And upthrust, for that we need upthrust. So first to To find the upthrust applied by the water, upthrust applied by the water, U is equals to density of liquid multiplied by volume of solid multiplied by gravity, if it is fully submerged. So volume of solid submerged, density of liquid into gravity, that is the upthrust applied by the liquid. Now density of the liquid we don't know, but we know in this question specific gravity we know. Specific gravity is specific gravity means density of solid divided by density of liquid, it is equals to 10. Means the density of solid is 10 times of density of liquid. Okay, or we can say that density of liquid is, okay, till here fine. Density of solid is 10 times of density of liquid. Now volume of solid we don't know. Volume, mass upon volume of solid is equals to density of solid. So volume of solid will be 2 upon density of solid. So 2 upon density of solid, 10 times density of liquid. Upthrust will be density of liquid multiplied by volume of solid, which is 2 upon 10 times of density of liquid multiplied by gravity. Rho L cancel. Now upthrust 2 upon 10 into gravity 10, 2 Newton is the upthrust. Upthrust force is 2 Newton. We found. Now, now we'll discuss about the free body diagram. This free body diagram. So, two forces acting upward, Fs2 plus upthrust equals to one force acting. It is in equilibrium, I am assuming, equals to 20. 2 into G. Now, Fs2 force on S2 will be 20 minus upthrust is 2 Newton, which is 18 Newton. Means on the reading scale of S2, spring 2 reading scale, 18 Newton will be force. Reading will be 18 Newton. Now on beaker, what are the forces acting on beaker? So beaker 5 kg mass, so 5 into gravity downward, upthrust downward. Now since it is compressing the spring, so spring force upward opposite to the displacement. The spring force Fs1 upward, right? Now upward force Fs1 is equals to 5g plus upthrust 50 plus upthrust 2 Newton, 52 Newton. So Fs1 value will be 52. Reading on the spring 152 Newton and reading on the spring 2 will be 18 Newton. 52 and 18. I hope I made it clear. Option third. Okay. Now the separation between successive fringes in a double set arrangement is X. If the whole arrangement is dipped underwater, the whole arrangement is dipped underwater, what will be the new fringe separation? So already fringe separation is X. It is dipped underwater. So fringe width will be old fringe width divided by refractive index. Refractive index already given. So solution will be easy. New fringe width B dash is equals to beta upon mu. Beta is X already. Previous fringe width divided by mu of water is 4 by 3. So it will be 3 by 4 times of X. 3 by 4 means 0.7 times of X. That is the answer. Now, a spring of a spring constant 5 into 10 to the power 3 is stretched initially by 5 centimeter from the unstretched position. The work required to further stretch the spring by 5 centimeter means 5 plus 5, 10 centimeter they have stretched afterward. So initially 5 centimeter spring stretch. So potential energy half k x square k into 5 centimeter, 5 into 10 to the power minus 2 to the square, half k x square initial. Now when they have displaced 5 centimeter more, 5 centimeter more means from the initial position, from the unstretched position, they have stretched it 10 centimeter, 10 centimeter. So now finally it will be half k 10 into 10 to the power minus 2 the square. Now remaining 5 centimeter, how much potential energy is there? So total stretch 10 centimeter minus initial stretch 5 centimeter. Then remaining 5 centimeter stretch potential energy, and remaining 5 centimeter we'll get half k common 10 to the power minus 2 to the square 10 to the power minus 4 also common 5 square 25 100 minus 25 100 minus 25. So k value also they have given 5 into something something, k value 5 into 10 to the power 3, 5 into 10 to the power 3. So uf minus ui into 5 into 10 to the power 3 10 to the power minus into 75. So 10 to the power 3 minus 4 minus 1, 10 to the power minus 1, 1 by 10, 1 by 20 into 5, 75, 5, 4 times 20, 75 by 4, 4 1 time 4, maybe 4, 4, 17, 20, 28, 4 times 32, 32, 32, 32, 3, 1 time 20, 75. So it will be this much of joules energy will be there 18.75. Yeah, option third. Now question number 8 is very easy. Question number 8, what they are saying is match the following: fluid flow because of the pressure difference, heat flow because of the temperature difference, and charge flow because of the potential difference. A E, B D, and C F. Eighth question, correct first option. Now next ninth problem they are saying is a simple pendulum of horizontal length L and mass M is initial at its lowest position. It is given that minimum horizontal speed necessary to move the circular path about the point of suspension. Minimum horizontal speed root 5 5 gr or 5 rg. Root 5 rg will be the minimum speed. It is given the minimum to complete a vertical circle. We have learned that at the lowest position root 5 rg will be the speed, minimum speed. So the tension in this string at the lowest position will be, so let's see. This is question number 8. So Bob is here in the lowest position, mean position. Okay. At the lowest position, speed is root 5 rg. V is equals to root 5 rg. Tension here, mg here, and centripetal acceleration toward the center. So T minus mg is equals to mass into centripetal acceleration v square by r. T tension will be mg plus m root v square. V square will be 5 rg. V value root 5 rg, so square of it. So 5 mg plus mg, 6 mg. Tension will be 6 mg. Now, if electric field and E vector and B vector are electric and magnetic field of the vector electromagnetic waves, then the direction of propagation of electromagnetic wave is third option, E vector cross B vector, which we have learned multiple times. Okay. Now, next question they are saying 1 centimeter on the main scale of a vernier calipers is divided into 10 equal parts. If the 10 division of the vernier coincide with 8 small division of the main scale, means 10 minus 8, 2 difference between the main scale, 10 divisions of vernier coincide with 8 small division of the main scale. The difference of the scale will be 2 divided by 10, 0.2. Least count will be 0, 10 minus 2, 8, 2, 2 by 10, 0.2. Least count will be 0, 0.02 centimeter will be there. I think we'll see. Initially, 1 centimeter of the main scale vernier caliper divided into 10 parts. So least count initially it was 0.1. Now, if the division of the vernier scale coincides with 8 small scale, so the original scale will be 10 minus 8. Initial least count initial will be 0.1 centimeter. Now, the original reading they are saying is the original reading they are saying is here. Initial least count 10 centimeter. Now, the least count of vernier is equal to number of division total 10 coincide with 8 by 10. So it will be 2 divided by 10. Okay. So this much of value multiplied by the least count 0.1, so it will be 2 by 100 is the new least count 0.02 centimeter. New least count will be 0.02 centimeter under this condition. Now, this 11th question completed of the first. Now, second one. Three identical particles with velocity v naught I minus 3 v naught j and 5 v naught k collide successively with each other in such a way that they form single particle. Okay, the velocity of the vector of resultant particle is, see, conservation of momentum, they are simply saying conservation of momentum, where initially all three are of equal mass, three identical, yeah, three are of equal mass. So m v naught I cap minus 3 v naught j cap plus 5 v naught k cap plus 5 v naught k cap. After collision, it will have the velocity, let's say v vector, v vector. So after collision, yeah, mass common and cancelled. So it will be mass coincide A I cap velocity, B j cap, C k cap. And the mass will be three times. Here mass will be m, all three. and here mass will be 3m. M to M cancel because all three have been combined. So 3a is equals to V naught. I component, I component. A is equals to V naught by 3. Now 3b is equals to minus 3v naught. B is equals to minus V naught. And 3c is equals to 5v naught. Is equals to 5v naught by 3. So velocity, final velocity will be V naught by 3 I cap minus V naught j cap plus 5 V naught by 3 k cap. So velocity vector after collision, 3 LCM will take, so V naught by 3 I cap minus 3 j cap plus 5 k cap. This will be the answer. So I hope by 3. Okay, option 4. Now work done when a force something something acting on a particle take it from the position. So position vector this R2 minus R1 we can do, and F vector dot product. Dot product. Here just only writing will take time. Remaining everything is easy. Uh, the problem is I'll take question paper from here so that again and again I don't have to scroll. So F vector they are saying um, I cap plus 2j cap plus 3k cap, and R1 vector I cap plus j cap plus k cap, and R2 vector I cap minus j cap plus 2k cap. R2 minus R1 minus R1 vector R2 1 minus 1 0 I cap minus j minus 2j cap 2k minus k. There is the position vector R vector. F dot R work done will be F vector dot R vector dot product 0 multiplied by 1 0 minus 2 minus plus 2 minus 4 1 multiplied by 3 1 minus 1 June, option 2. Okay, in your answer sheet what is the answer given? Very much. Question number 13, option 2, correct? Option 2. Now next question they are saying when a current carrying coil is situated in a uniform magnetic field with its magnetic moment anti-parallel to the field. Magnetic moment anti-parallel to the field means 180-degree angle. 180-degree angle, unstable equilibrium, potential energy maximum. Equilibrium it will attain minus P cos theta. Cos 180 degree minus 1. Or M B cos theta if I will say. Here Pe cos theta will be for electrostatics. For magnetostatics we will say MB cos theta. Potential energy MB cos theta cos 180 degree minus 1. So MB potential energy will be maximum MB. So PE maximum, and potential energy maximum, and torque will be torque is equals to MB sin theta, sin 180 0. So torque will be minimum. So option 2 and option 3 is correct. So option 2 and option 3 correct. Okay, question number 15 we'll see. Question number 15, particles of masses m, 2m, 3m, so on up to nm are placed on the same line at a distance L, 2L, 3L up to NL from origin. Okay, the distance of center of mass from O is, it's so Here origin is there at L distance, M mass at a 2L distance, 2M mass at a 3L distance, 3M mass from the origin, and so on up to N into M, which is at a distance N into L. Just a sec. I'll put the charger. N into L. Now, center of mass will be M into M1 R1 plus M2 R2 plus M2 M3 R3, so on. The position of center of mass, axis center of mass will be M into L plus 2M into 2L. So 2 square ML plus 3M into 3L, 3 square ML, so on into N square plus N square ML divided by M plus 2M plus 3M, sum of the masses, so on up to Nm. Now axis center of mass, ML common, M common, numerator denominator 1 square plus 2 square plus 3 square, so on up to N square divided by 1 plus 2 plus 3 plus so on up to N. M to M cancel. Axis center of mass, L multiplied by N into N plus 1 into 2N plus 1 by 6 divided by 1 plus 2 plus N into N plus 1 divided by 2. N into N plus 1, N into N plus 1 cancel. 2, 3 times 6. So 2N plus 1 L by 3. This is the axis center of mass. This is the answer. Hope this is clear. Now, option 4. Question number 15. Option 4 correct. Now, the value of current in the following diagram is a diode assumed to be idle one. Now, here negative potential -4. Here -1. Means -4 is more negative than -1. -1 is bigger than -4, right? -4 is smaller. So current will start flowing from here. Now negative, it is positive, right? This part is positive. Positive connected to negative part means it is in reverse bias. If the connection is in reverse bias, there is no current flow. If it is an idle diode, it will not allow the current to flow, right? Now question number 17. Two bodies are thrown with the same initial velocity at angle theta and 90 minus theta. Question number 17. So, one angle theta, one angle 90 minus theta. Speed is same, initial velocity same. Okay. Thrown with the same initial velocity, angle theta minus 90 minus theta respectively with horizontal, then their maximum height are in the ratio. Maximum height if we are talking about. Maximum height h max when the angle is theta or h1. Maximum height in the first case u square sin square theta upon 2g h2 u square sin square 90 minus theta which is cos square theta upon 2g. So h1 is to h2 will be u square by 2g, u square by 2g cancel. Sin square theta is to cos square theta. So it is option number third. It is option number third. Right? Now, these are multiple circuits in 18 question. Now, In the first case, when this connection is there, here A terminal, here B terminal, A potential here also, here also. If here B potential, here B potential. Between A and B, first capacitor, second capacitor, third capacitor. Means all the three are between A and B. Three capacitors are there. All three and between A and B. Three capacitors are parallel. So 3C. So A with G. Now here A, here B potential. Between A, B, two capacitors are there and one capacitor short circuit. Means we will not consider that. So 2C. 2C means B is F. AG, BF. AG, BF on the first combination is same. Hmm. And if you want to see this part, this is A, this is B, and this C here. Between AC, one capacitor, between AC, second capacitor. So two are in parallel, and third is in series with this C capacitor is in series BC, between BC. So 1 by 2C plus 1 by C is 1 by C equivalent. If so, it will be 2C by 3, 2C by 3. So C or E. Further, if you want, I'll tell you. Statement number 19. Negative charge always move from higher potential to lower potential. No. Negative charge always flow from lower potential to higher potential. Positive charge flow from higher potential to lower potential. First statement false. Electric potential is vector. No. Potential is scalar quantity. E and B both are false. 19. Both are false. Correct. Now question number 20. The viscous force F on a sphere. Viscous force is F is equal to 6 pi eta RV. 6 pi eta RV. If I will say eta value, F is equal to question number 20, I think. Yeah, it is 20. Dimension unit dimension we need. So 6 pi eta RV. 6 pi no unit. Eta is equal to Newton per meter into velocity meter per second. R will go the other side. So Newton per meter square into per meter square means Newton per meter square into seconds. This second will go numerator. Now, in that Newton is m l t to the power minus 2 mass into acceleration meter per second square m l t to the power yeah m l t to the power minus 2 into t to the power 1 divided by l to the power 2. So m l to the power 1 minus 2 minus 1 t to the power minus 1 m l to the power minus 1 t to the power minus 1, that is the dimension of viscosity. Fourth option, right? Now question number 21. A current of 1 by 4 pi ampere is flowing in a long straight conductor. The line integral of magnetic induction around a closed path enclosing the current carrying conductor is line integral b dot dl, closed integral of b vector dot dl vector is equals to mu naught into total current flowing through it. Current is 1 by 4 pi and mu naught is 4 pi into 10 to the power minus 7 into 1 by 4 pi. So 10 to the power minus 7, that is the total flux. Per meter. Sorry, 10 to the power minus 7. What I am doing? 10 to the power minus 7 Weber per meter. So 10 to the power minus 7 Weber per meter. That will be there of question number 21. Sort. Now question number 22. In nucleus, X235 splits into two nuclei having a mass number in the ratio 2 is to 1. The ratio of the radii of two nuclei. Radii and mass number have a special relation. Radii is directly proportional to atomic mass number to the power 1 by 3. So radii 1 by radii 2 is equals to a1 by a2 to the power 1 by 3. A ratio they have given already, having mass number ratio 2 is to 2. So their radii will be in the ratio 2 is to 1 to the power 1 by 3. Cube root of this. So this is question number 22. Very simple. 2 to the power 1 by 3. Option third. Now, question number 23, they are saying three equal weights A, B, and C of mass 2 kg each are hanging on a string passing over a fixed frictionless pulley as shown in the figure. The tension in the string connecting weights B and C is approximately. All are in equal weight 2 kgs. Frictionless pulley. Here 2 A part, B 2 kg, and here also 2 kg. Now this side 4 kg, so net acceleration will be in this direction, here this direction. Here T, here T dash, here T dash, here T, mg, 2g, here 2g, here 2g. When we are talking about net acceleration, so from A point we can say T minus 2g is equals to mass into acceleration, equation number 1. And this B and C combined, this 4 kg, 4 mass, 4 kg mass, right? And acceleration downward. So 4g downward minus tension, basically this part only is carrying tension, right? This is string. Minus t is equals to 4 times of acceleration, equation number 2. If t value will find, t dash immediately will be able to find, no problem with that. So plus t minus t cancel. 4g minus 2g, 2g is equals to 6a. A is equals to 2 6 g by 3. Acceleration due to gravity, g by 3. Substitute this value. So of acceleration, t minus 2g in equation 1, 2g by 3. So 2g plus 2g by 3. 6 plus 2, 8g by 3. Tension will be 8g by 3. Now T dash we have to find. Tension in BC string connecting BC. So from here we can see that T dash in under equilibrium condition, for a moment we will stop the motion. Under equilibrium, T dash T upward is equals to T dash plus 2g. Upward and downward force are equal. Now under this condition, T and dash T value 8g by 3 minus 2g is T dash 2g into 3 and 6. So it will be 2g by 3. 2 and 2 acceleration due to gravity by 3. 10 by 3, 3.33 into 6. No, we cannot stop for it. So this equation is correct. T tension correct at g by 3. This equation is not right. Here only problem will be there. So dash is equals to, if the B acceleration will be 2 kg and 2 kg both are moving with downward acceleration. So if the equation final equation is wrong because acceleration downward, so T dash downward positive plus 2g minus T is equals to mass into acceleration. Acceleration we already know this. So T dash plus 2g minus 8g by 3 plus 2 times is equals to 2 times of acceleration, 2 times of acceleration g by 3. So t dash is equals to 2g by 3 plus 8g by 3 minus 2g. T dash downward t dash 2g minus t is equals to 2 times of acceleration. Here it will be 10g by 3 minus 2g. So 2 times 6, 10g minus 6g by 3, 4g by 3 means 40 by 3 approximately. 40 by 3, 3 1 10 3, 10, 3 3 10 9, 13.33 will come, which is 13 Newton approximately. Answer will be 13 Newton. I hope that this will be the answer. Remaining process is totally correct. There is no need to worry about the process. Only thing, little decimal is coming. No worry here. Now 24. Question number 24 we'll see. Question number 24, what they are saying is, in a given circuit as shown that two input waves forms A and B are applied simultaneously. So simultaneously the resultant wave of Y is. Now see here. Here input of A is 1, here 0, and here 1, here 0. For B input 1, 0, 0, 1. Right? So first input and Y is equals to A plus B. Whatever input you will give, it will add. So when you are giving A input and B input 1 1, so it will become 0 0 here. 0 plus 0 is 0. Initial part will be 0. Initial graph will be like this 0. Now when we will substitute both place 0 0, 0 0 here, 0 here, 0 here, so it will become 1. 1 plus 1 is 1, carry 1. So it will be 1. Then 1 0 when we are giving the input, 1 1 place 1, another place 0. 1 1 becomes 0, 0 becomes 1, and we'll add 0 plus 1 is 1 only. So again input 1, and then 0 and 1. So again 0 and 1 input will be 1 only. So 0 1 1 1. This is the only graph which is representing 0 1 1 1. Right? So option 1 is the correct one. So I hope you understood. If there is any doubt, you can immediately call and ask. Right? Now, a galvanometer of coil resistance 100 ohms is connected to a shunt of 10 ohms. The current through the galvanometer is I1, current through the shunt is I2, and total current I3. Then the ratio of the current, 100 and 10 in parallel they are talking about here. It is question number 26. Sorry, no, 25. 25. 25. So galvanometer of resistance 100 ohms, a shunt of resistance 10 ohm, current I1 is flowing through galvanometer, I2 is flowing through the shunt, and I3 is flowing total current. Right? Now they are asking ratio of the current. Now see, net potential throughout is same, only how much potential you will apply here That potential will be here also in parallel connection, potential same. So here also same potential. Here also same potential. Here also same potential. Total also same potential. What is the total resistance or equivalent resistance here? Multiply parallel connection. 1,000 into 10,000 plus 110. So 100 by 11. 100 by 11 ohms. Now potential here, potential IR, I1 into R 100 is equals to potential uh, potential here, the first case potential equivalent I1 into 100, I1 into 100 is equals to I2 into 10 is equals to I3 into 100 by 11 ohms. Total current, total equivalent potential. So I1 by I2, 10 by 100, 1 is to 10, and this total divided by I3, this is divided by I3 200 by 10 I3 100 by 11. I1 is to I2 is to I3 they are asking. Ratio of the potential is 1. I1 I1 by I2 is equals to 10 by 100, we already know, 1 by 10. I2 by I3 by I3 is 100 by 11 into 10. 10 by 11, 10 is to 11. Okay. So I1 is to I2 is to I3. I1 is to I2 is to I3 will be 1 is to 10 is to 11. Right. Question number 25. 25, 25, 1. 1 is 1 is to 10 is to 11. Yeah. Now, when the number of turns of in the two circular coils closely wound are doubled in both, then their mutual inductance becomes. So N1 and N2 both are doubled, and mutual inductance depends on N1 into N2. So 2 times of N1 into N, 2 times of N2, 4 times of N1 N2. So it will become 4 times, right? Now, the force required to just move a body up the inclined plane is double the force required to just prevent the body from sliding. Just prevent the force, body from sliding. Then the coefficient of friction is mu. Just move body. So one time we'll see question number 27. Just move the body up the inclined plane. Just move the body up the inclined plane. If the angle theta is there, force required to just move the body above the inclined plane. So upward we have normal here mg cos theta here and mg sine theta here. So just move the above, just to move the above inclined plane. So net force will be, here friction force will be there. If the friction is available, then yeah, friction is available definitely. Yes. If friction is available, then friction here. F will be there. F is mu into n. So F is equals to mg sine theta plus friction force mu into normal. Normal is mg cos theta. Just to move over, this much of force required, and just to prevent from sliding. Means if the body is here, now you are applying force, is trying to roll down mg sine theta in this direction, mg cos theta normal. Just to prevent, the friction will be in this direction this time, and force applied will be this direction. So force plus F is equals to mg sine theta. In that case, force in the first case, force in the second case, mg sine theta minus friction mu n, mu into n. N is mg cos theta. Mg cos theta. F1 is 2 times of F2. F1 is 2 times of F2. Mg sin theta plus mu mg cos theta equals to mg sin theta minus 2 times 2, 2 mu mg cos theta. Now this will go this side and this will come this side. So 3 mu mg cos theta is equals to 2 mg sin theta minus mg sin theta. Mg sin theta, mg முடிஞ்சு, cos theta will go other side. 3 mu is equals to sin theta upon cos theta tan theta. Tan theta is equals to 3 mu. So question number 27, 3 mu. Question number 27, 3 mu is the answer. Now question number 28. We will see. The current I in an inductor coil varies with time according to the graph shown in the figure. Which of the following graph shows the induced EMF? Induced EMF, if we are talking about, induced EMF is minus L di by dt. Right? Negative. So initially, current is a constant up to this point, right? From here to here, current is constant, means di by dt is 0. So in that case, di by dt will be 0. So second option, third option, and fourth option showing di by dt 0 means EMF 0. In the EMF graph, the second, third, and fourth option showing the 0 EMF. So first option cancelled out, ruled out. Now second thing, here to here, current is decreasing. Rate of flow of current with the time is decreasing. So EMF must be increasing because minus di by dt. So if di by dt is coming downward, then with a constant rate, in a straight line, so EMF increasing with a constant rate, right? Option 4. Then here di by dt increasing, so EMF is decreasing. See option 4. Option 4 is the correct one. Question number 29. 29 is easy because that potential in L, VL and VC are equal. It is a resonance equation. In that case, potential will be 100 volt, which is only going through the resistance, because V net is equals to net potential is VR only. In that case, VR 100 volt, and current through it will be, through the circuit will be V equals to IR. So I is equals to V by R, 100 by 50, 2 ampere. Option 1, 29, option 1, 29, option 1, correct. So up to question number 29 we have completed. It will take a little bit time to complete the remaining 15, 16 problems are there. For now, that much is enough. Further, we will see in the next class.